let us start the session. Okay. What we are going to discuss today is Division 1 or Division 2. Whether Division 2 is the future. So if you have to make that decision, what are the factors you think we should talk about to decide whether that is going to be the future or not? So all the factors which are influential for taking the decision, like factor of safety, complexity of design. If the design is very complex, it will be difficult for people to adopt, right? Material. Okay, in terms of material, if I'm selecting a material, whether Division 2 is more restrictive than Division 1, whether there are lots of exceptions or limitations given to the material. Okay. So that will play a part. Okay. Use of FEA. Okay. Whether we need to use FEA all the time when we are using Division 2. If the answer is yes, then it will be costlier, right? ND, which already discussed about, if ND is, the extent of ND is very high, it will result into cost, right? Then documentation. Documentation is also very important, right? So if you have to produce lots of document, that means your cost will be higher, right? Then certification. What type of certification you're talking about? What is basically the certification? U2 stamp. Okay. So what are the documents which need to be certified? What are the documents which need to be certified in a job? UDS and MDR. So UDS is nothing but user design specifications. Okay. So any input which is provided to you, that also needs certification. Okay. But not always. Okay. So we'll talk about that also. Okay. So certificate of compliance, very good. Okay. So these are the basically factors which we will be talking about. Okay. So before we go into very much detail, because many of you might not be aware of the structure of Division 2. So we'll just highlight the structure for you. So you can see the structure is completely different than Division 1, right? You can see part 1 with general requirement. The general requirements in Division 1 is very large. Okay. It's UG, which covers most of it. Okay. It covers design, material, okay, even fabrication, tolerances, inspection, everything. But here the general requirements are very small. Okay. It is just related to what kind of document, class 1, class 2 definitions. Then part 2, which is also very small, responsibility and duties. Part 3 talks about the material requirement. Okay. And part 4 and 5 are basically your design by rule and design by analysis part. Okay. These are the two parts which are, as a designer, very, very important for us. Okay. Fabrication requirement in part 6, part 7, inspection requirement, part 8, pressure testing, and part 9 as overpressure protection. Okay. So these are the things which are there in Division 2. Okay. So this was just for information to, so that structure is a little bit clear to you if you are new to Division 2. Okay. So let us start with the first factor, the differentiator factor. The first factor is factor of safety. Okay. So can you tell me what is the factor of safety in Division 1? 3.5, right? So, okay, so because the factor of ultimate tensile strength, that is what we call as factor of safety. Okay. If the material allowable is governed by yield strength, then 3.5 will not be your factor of safety. Okay. But most of the time it is governed by UTS, so we can call it as factor of safety. Okay. So it's 3.5. So in 2017, okay, before 2017, Division 2 was not having class 1 and class 2. Okay. Many of you may be surprised with that. Before 2017 edition, there was no class 1 and class 2. Class 1 and class 2 were introduced in 2017. Okay. So Division 2, like we said, we have two classes, class 1 and class 2. Okay. For class 1, what is my factor of safety? 3. What is the factor of safety for class 2? 2.4. Okay. Great. So now the interesting part starts. If division 2 comes into your mind, like if you see division 2 code, we always think that we have to perform FEA. So what is the answer for that? Do we need to perform FEA if my code is division 2? No, we don't have to do FEA for division 2. Okay. But when this was followed, like before 2017, that was not the concept. Okay. When you are following division 2, you have to do FEA. Okay. Now, if you're using class 1, now let us talk about the classes, because your requirement will depend upon which class you are following. Okay. So if your class is 1, do you need to perform FEA? I'll make it easier for you. In division 1, no, whenever I'm saying division 1 or division 2, I'm talking about ASME section 8. Okay. So in division 1, do you need to perform FEA? Sometime yes, right? Sometime yes. U2G, when there are no rules available, okay, then if fatigue is there, okay, creep is there, okay, if the design is such that there are no rules which we can fit in, then we do FEA, right? Same case is there with division 2 class 1 also. If rules are available, you don't have to perform. If fatigue is there, then you have to do part 5. That means FEA. Okay. So only if rules are not available or fatigue is there, then only you have to go with FEA. Okay. Otherwise, you don't need to do finite element analysis for division 2. Okay. Class 1 components. Okay. Now, this is very interesting. For class 2, do you need to perform FEA? The answer for that is, okay, for class 2, you don't need to follow design by analysis or part 5. Class 2 also you can do as per part 4. Okay. So considering there is no fatigue, no rules are missing, like all the rules you are having, then for class 2 also you can have design by part 4, design by rule you can have. Class 2 does not mean part 5. Class 2 only means that allowable is different. Okay, you have to follow different table for allowable. Factor of safety is 2.4. Okay, that is what class 2 means. Okay, so by factor of safety, you can see the difference. Is it making sense, guys? So class 1, no need to do FEA if fatigue is not there and all the rules are available. For class 2 also same. Okay. Now, I'll ask again one question related to class 1. Okay. If the rules are already there for class 1, right? For class 1, we are following part 4. There is a formula for thickness calculation. Can I use part 5 and overrule this design? Listen to the question very carefully. Okay. If design by rule is available, my design is class 1. Can I overrule the design by rule part and optimize the thickness by doing FEA? So no, you cannot overrule the calculations of part 4 if the class is 1. Okay. See the difference. Okay. We are talking about all these differences. Class 1, you cannot overrule the thickness, similar to division 1, right? Division 1, if the formula is available, I cannot use FEA to optimize the thickness. Okay. So you cannot do it. Now, if class is 2, then if class 2 is there, can I overrule the design by rule part 4 and use part 5 for class 2? Can I overrule the thicknesses calculation? Can I overrule the thickness by calculation by part 4 and use FEA to design the component? Can I do that? Answer for this is yes. If class 2 is there, then you can overrule part 4 calculation, the equation, and use part 5. Okay. So for class 2, that is permitted. If it is class 1, then it is not permitted. Okay. So these are the points which, if it is not clear in the start, it will be very difficult for you to even quote. You can wrongly quote for the job and it will be costlier for you. So remember the differences. Okay. So even though you are not using division 2, but you should be familiar with these things. Great. So factor of safety. Now, how we'll conclude? For division 1, factor of safety is 3.5. Okay. So if we compare that with class 1, we have factor of safety as 3. So if we just see the cost of material, how much roughly saving you will have? If you compare the factor of safety 3 to 3.5 of division 1, how much saving you think can have? Just to tell in terms of percentage, just take the ratio and convert that into percent. 15. Okay. So 3 divided by 3.5 at the percentage, so around 15 to 18%. Okay. Now just compare that with class 2. If the same equipment I'm designing with 2.4 factor of safety and I'm designing with 3.5 factor of safety, how much saving in terms of percentage you have? Roughly 30%. See, so if the size of the material is large, okay, and pressure is high, that means thickness is also large. That case, 30% saving means a lot, right? So for bigger size equipments with pressure roughly in range of more than 20 to 30 bar, it starts making sense to design it with division 2. Okay. See, now these things are not written, but just, because size is also a very big part. So basically, when in deciding, you'll have to compare, okay, that what is the fraction in which cost is saved in terms of material. And we'll talk about the other factor also, like ND, how much it is increasing in due to material restrictions, how much it is increasing. So it makes sense, right? At this point, based on factor of safety. So let us go to the next factor, complexity of design. Okay. So complexity of design, when we talk about part 5, you all know that FEA will be there. Okay. And if fatigue is there for division 1 also, you'll have to use the same methodology. Okay. But if we talk about part 4, design by rule, do you think it will be cost wise in terms of, okay, first forget about the cost. Just think about the complexity of design. So what do you feel that calculations are compared to division 1? How does that look? How does that compare with division 1? The calculation which you have, more rigorous, right? So very rigorous. And if you see, very, very long equations are there. Okay. And if you see the external pressure design, it's like so much iterative. Okay. External pressure design is so much iterative that you have to write a code to do the iteration. Okay. You need to write a code. It will not be there in Excel. You cannot do unless you write micros in Excel. iteration, you won't be able to do it. Okay. So even when you know, discuss with ASME committee, they always think that now the time of doing the design in Excel sheet is over. You have to follow some of the softwares which are available. So if you're following, considering that you're following software for doing that calculation. So if you're doing the calculation manually, it is very, very regressive. Okay. Very, very regressive. It will be very difficult for you. Okay. But now, if you are using software like PV Lite or Compress, then whatever, it's division 1 or division 2, does it make any difference for calculation? The complexity, does it matter for you during the design? Let us say everything is passing. Okay. You're not stuck in some clause which is providing or making error or warning. So do you think it will make difference if you're using code? The complexity of design, will it make any difference? No, right? No. Similar input is there, no additional input. Okay. You just have to select the design code as division 2 and class 1. That's all. Okay. So the design is complex, but if we talk about doing or performing the design with softwares, it does not make any difference for a company. Okay. So if you are having same license, both are covered. So no additional cost, right? Definitely for engineers, if you're talking about experience and all, you need to have a higher experience engineers, right? So that will make a difference. Okay. Great. So complexity of design here also, if you see, does not make much difference in deciding whether division 2 is future or not. Okay. Let us take the next. Okay. We'll build some more point of the in complexity of design. Okay. Like design rules of welded joints. Okay. There are lots of calculation given for division 1 also and division 2 also. So if you see division 2, that is a subset of division 1. Lots of types of welded joint which are permitted in division 1 might not be permitted in division 2. Okay. So it's a subset. So few joints are taken, others are eliminated. They are not used. Okay. So they are not permitted in division 2. Design rules for internal pressure. It's a new technology, new formula. Okay. And evolved formula, much evolved formula. So it will give you the thicknesses very accurately. If you talk about external pressure, that is completely to the next level. The calculation, if you see. So if you might have referred code case 2286. So that is what is adopted, but it is written in a very detailed manner. Okay. So again, external pressure is adoption of CC code case 2286. Okay. Shell opening in shell and heads. The reinforcement calculation. The methodology is completely different in division 2. Okay. In division 1, how do we calculate reinforcement? What is the main point for us to calculate the reinforcement? What is the basis for us to calculate the reinforcement? How we calculate the reinforcement? Area, right? So we basically work on compensating the area, right? Area lost, area compensated. But here it is completely different. Okay. It calculates the maximum allowable working pressure, okay, for that opening. Okay. So it calculates the MAWP for the opening. So the procedure is completely different. Okay. So it's very interesting. So that is also based on new technology. So all the advanced things, you can see they are coming in division 2. Okay. So what do you think the focus of ASME is? Okay. Next, evaluation of vessel outside tolerance. So if your vessel is outside tolerance, how you will evaluate that? Okay. So here there's API 579. the methodology of that is adopted here. Okay. So API 579 and ASME, FFC, fitness for service, that is what is used here. Okay, but that is also a new technology. Okay. Great. So next, many other clauses. Many other clauses you will find they are rewritten. Okay, so many appendices which are there, mandatory appendices, they are part of the main calculation, part 4. Okay, and they are rewritten in a better way so that understanding of those will be very clearer to you if you refer division 2. Okay, so if you go through division 2, that understanding of those will become much clearer. Okay, so that is about the complexity, but because you're doing it with software, so does not make much difference for you. Okay, now if we talk in terms of material, which one do you think will be more stringent towards material? What is your opinion? What do you think will be more division 2, right? Which is more stringent? There are lots of limitation which are there. We'll talk about that. Okay, few of them, not all. So if you just see about the structure is very clear. It refers different tables for different types of material. Like carbon steel, you have a table. Quenched and tempered, you have a table. High loss steel, you have a table. You just go to that table and you'll see all the allowable material specification. Okay, so that way it is very similar to division 1. Every material is listed very properly. But then there are lots of limitation, like if we talk about few of them. So chemical requirement for carbon steel, the carbon content, you cannot have more than 0.35%. Okay, so 0.35% is the limitation for carbon content. If you talk about ultrasonic examinations of plates and forging, there is no requirement in division 1. Okay, but generally we do ultrasonic examination for thicknesses above 50 mm, right? So do you know from where it is coming? It is coming from division 2. Okay, so in division 2 also, above 50 mm forgings and plates you need to have for all the materials. Okay, it is for all the materials you need to have ultrasonic examination to accept that material. Okay, so it's also very uh, cost wise, it is affecting factor for division 2. So your cost will increase. Similarly, for testing, welding, there are lots of additional tests required, okay, in terms of material. Okay, when you are purchasing it from mill, welding wise, lots of additional qualifications you need to have. Okay. So if you talk about material, including your welding, definitely division 2 will have more cost. Okay, but if your vessel is very large, okay, and pressure is high, typically this cost of doing this additional test are all less than 1%. Okay, so they do not influence the total cost much, so will not be much a factor in deciding. Okay, use of FEA we have already discussed. So based on class 1 and class 2 and the requirement, you need to go for FEA. So it's not like that concept which we typically think that division 2 means FEA. That is not true. Okay, you can do it without FEA. Okay, and that is why class 1 was created, and that is how ASME is trying you or projecting division 2 for all of us to use. Okay, see, this is where European codes were having advantage. So EN 13445, if you see, you have all these calculation, advanced technology, okay, which was missing in division 1. Okay, so ASME was losing in that. So they are working a lot on division 2 and making it more easy to follow also, so that you don't, if you require FEA all the time, then people will not use it, right? Because not only the cost, but expertise is also important, right? So if we talk about ND, non-destructive examination, what do you think? Which one will be more? So typically in, what we think is which one will be more stringent in terms of ND? Division 2. But do you think it is different with a great extent or minor? The difference is minor, or you think it will be a great extent? Like most of the time it will be 100%. What do you feel? Definitely difference is there. Okay. And division 2 is having higher requirement. The difference is not very large. Okay. Difference is small only. Okay. So if you see this table, okay, the extent of non-destructive examination depends upon different groups. Okay. So I'll not explain the to you the examination groups and all in detail, because that is off topic. It will require lots of time. But just to notice or remember, you can see there are multiple examination group. Okay, 1B, 1A, 2A, 2B. Okay, so you can have any of these examination groups. Okay, so if I'm having 3A or 3B, your ND requirements will be much lower. Okay. If you are having 1A, then it will be kind of matching with radiography 1, RT1. Okay, now you can see here, on the screen you can see RT. Apart from RT, you have MT and PT also taking, mentioning in code, because that we don't see in division 1, right? We anyway perform PT before doing RT. Okay, that is the normal practice. But that requirement is not there that 10% is mandatory. But here, that is given. So you have to document it properly, the PT requirement. Okay, so that is very much required. So that is kind of additional which you will have. Other than that, if you see based on different joint category and type, once your examination group is fixed, okay, you will have almost for all the different categories, you can write down what is the radiography requirement, okay, and MT and PT. So it's very structured in that way. Okay. So you can conclude it like it's not very high, it's very similar to what we have. Okay, but that is see, when division 2 started, do you know what was the radiography requirement when the division 2 was started back in 1960s around? So when division 2 was started, the first introduced, it was 100%. Okay. So that is how the difference was, like too much for division 1 and division 2. So for all the wells, whatever you are doing, you have to have 100% radiography. Okay. So you cannot have a nozzle without stub. You need to have a nozzle with extension so that you can weld it. Okay, with lip, nozzle with lip were required. Okay, so that was the starting point, but later on they started reducing it. Okay, fluid out connections. Yeah, so that is what you need to have for 100% radiography. Great. So, but now it is very much comparable, and that is the reason you are the uses of division 2 is becoming more prominent and frequent. So if you talk about documentation, then definitely documentation, because each and every stage that design is complex, so your calculations will be very large. So pages of calculations will be more. Each and every stages you'll be preparing more documents in division 2. So if you think in terms of documentation, then yes, documentation for division 2 will be much higher. Okay. Great. Now, certification. You're talking about certification, right? So what is the document with which we start? UDS. Okay. So UDS needs to be certified all the time. See, whenever we are talking about the requirements, okay, we are talking about the stamped jobs, right? If the job is not stamped, then does not mean you can follow anything, based on whatever you like. Okay. So requirement means it is a stamped job. Okay. So then you have to follow the code in complete manner. Okay. So UDS certification for class 1, is it required? So the answer is yes. Fatigue, if fatigue is required, okay, and your class is 1, then yes. Otherwise, no. Is it making sense? UDS certification. Okay, when I say certification, what I mean by certification, who certifies UDS in these kinds of certification? P. Okay, so remember that certifying engineer, which are professional engineers, international P. Okay, not chartered engineer. Chartered engineer of some countries. Okay, so basically they are called as certifying engineer and professional engineer, international professional engineers. Okay, so those are the certifying authorities. So that has to be certified. UDS has to be certified. So if I'm the client and I have to make one UDS, I'll prepare the UDS, get it certified by a professional engineer. That will be my duty before issuing to the vendor. UDS is nothing but user design specification. Okay. So it's a kind of input document. Okay. All the combined input that has to be certified and then given for design. So isn't that good? That is what should be followed, right? So they are following it for critical things, but as a designer, we always feel that it should be there for all the jobs. Okay. So it will reduce lots of problem if the input which is given to us is checked that it is complete and accurate, right? So completeness is also very important, right? All the data which is required for design, that is given or not, that is what is basically checking of UDS. Okay, making sense? Now, for class 2 again, does not matter if it is fatigue is there, then it is certified. If not, then it is not certified. Okay. Next document will be MDR. So MDR will be prepared by the vendor or the manufacturer. What do you think? MDR needs to be certified all the time. MDR, which is a manufacturer design report, do you think it needs to be certified by professional engineer? For MDR, if it is class 1, do you think it needs to be certified all the time? The answer is no. Okay. When you need to certify the MDR for class 1? When there is fatigue or you are following part 5. Okay. Some calculations were not available. The design by rule was not available and you had to perform FEA. Okay. In that case, if FEA calculations are included or fatigue calculation is there, then MDR need to be certified by professional engineer for class 1. For class 2, MDR certification is mandatory. Okay, you need to certify for all the cases. Making sense? Great. So now let us conclude this, that what exactly you come out, because we started with whether division 1 or division 2. Okay. So the answer is if the pressure is in the range of 20 to 30 bar. Okay. And the size is big. Okay. Now I'm not mentioning the exact size of the component. Okay. Because all this decision is taken on what is the saving of the material cost and versus the increase in the cost of ND and testing and welding qualification design. Okay, everything combined. So reduction of cost, if it is significant, then it definitely takes care of your all the other increased part. Okay. So definitely, yes, division 2 will be lot more profitable or cost saving if you are having a high pressurized equipment and the size is big. Okay. Because unless the size is big, the saving in the cost of material will not be very high. Okay. So hope it's making sense. Okay. But let us see, in PTB 1 statement is written that also you can, PTB 4, that class 1, you can see 2017 edition, the class 2 classes were introduced and the purpose was to attract more users to division 2. So that is what, ASME is trying to do by using division 2. Okay, so it is trying to attract more users, and in future also all the technology which they are developing, they are including in division 2. Okay, so they will be keep on improving. So if you see 2023 edition compared to 2021, the changes are enormous. Okay, too many changes. Okay. All the time it is happening with division 2. So that means it is in very much focus. Okay, great. So now see, we have created one course with ASME Section 8 Division 2. Okay, so I'll talk about the syllabus also in detail. So, and if you are willing to learn with us, definitely, we can continue this journey of learning. Okay. So ASME Section 8 Division 2, whatever course we have created, okay, that is covering entire Division 2. Okay, apart from FEA part, so the clauses which are required for FEA, that we have kept aside. Whatever it is required, like part 5 we have covered. It's not like the part 5 we have not included. Part 5 is required for you as a report reviewer. Okay, so anytime if you are reviewing a report or submitting a report from your side, it may be done by your colleague, so you can provide some input. Okay, so identifying the stresses, types of stresses, from where the stresses should be taken, to which it is compared, that allowable part, everything we have covered. Okay, so let us see the syllabus of it. Okay, let me share the syllabus part of it. Okay, so we'll be covering all the 9 parts. Okay, starting from part 1, part 2. So if in part 1 we'll be covering scope, then definitions, and then guidance, whatever it is there. Okay, so we'll be having 2 sessions on that, and then two sessions on part 2, which will basically talk about the UDS preparation. What should be the content of UDS. Okay, we'll be also preparing one UDS format which you can use for all the jobs. Okay, so manufacturer's responsibility. Okay, design report, if you are preparing as a manufacturer, what should be the content of it. Okay, that also will be covering. And then material requirement, about material, like we saw, lots of restrictions are there, additional requirements, so we'll learn about them. Then in part 4, if you see, it's very, very detailed. Okay, lots of additional calculation you'll see here. Okay, and most of the calculations which are there in appendix, mandatory appendix, okay, that is also covered here. Okay. So you can see, starting from the different design loads, types of loads, type of components, designing of internal pressure, external pressure, combined loading and allowable stresses, cylindrical to conical shell junction design. That is the additional calculations which division 2 is having. Okay, you can calculate the local stresses. Okay. So very interesting. Permissible out of roundness, everything, like you can see all the clauses which are there, we have tried to cover. Okay. Whatever is relevant for you as a designer, we have covered that. Lug support, skirt support, evaluation of vessel outside the tolerance, that is also we have covered. Okay. So all the details are there. Okay. Design by analysis, part 5. the load and load cases, which are very, very important. Load combination parameters, load case combinations, examples of stress classification, which will be required for you as a report reviewer. So stress categories. So all that we have covered. FEA part is not there because the intention is not to make a FEA person, because that will require lots of software training. When we talk about FEA, that modeling and using the FEA tool itself is a massive task. So that is the reason we have kept that aside. Inspection. What are the different examination groups and what are the joint efficiency requirement and how to read the different radiography and MTUT requirement, that all we'll see. Okay. Pressure testing and overpressure protection. Okay. These are the two remaining things. So this is what will be the complete syllabus. Total roughly 60 hours of session will be there, and we'll be taking around 3 to 4 months to complete it. Okay. So if we talk about the duration of the course, it is around 60 hours of live training. We'll have online sessions, live sessions will be there. Okay. It's not recorded, but recording also will be available. Okay. So the recorded class will be available with you, but our interaction will be live. So we'll be covering all those details in live class. Okay. We'll be either conducting once or twice in a week. Okay, depending upon the availability of the people. We'll be fixing it after we form the batch. So roughly 2 hours each day and 2 or once in a week. That is what we'll target. Whatever recordings, the access you will be having for 2 years. Okay, so that will be available for 2 years with you. The batch is starting from 4th June. Okay, so you have time. Okay, so we'll be starting at 4th June, but before, like if will not wait for the batch to form till that time. Okay, we'll be forming the batch much earlier and we'll be guiding something for them to read, to start reading. Okay, so we'll try to start it much earlier, that learning part, but actual classes will start from 4th June. Okay, so thank you guys, thank you for attending.